Alright, guys, so now let's start the chiral molecule. So, what is actually chiral molecule? A chiral molecule is one that cannot be superimposed on its mirror image. So, what does this mean? That it is non superimposable on its mirror image. It is non superimposable on its mirror image. So, what does that mean? And an asymmetric carbon atom. An asymmetric carbon atom means this each and every carbon atom will be attached to four different atoms or groups of atoms. Each carbon atoms will be attached to four different atoms or groups of atoms. Okay, let's say this carbon atom is attached to four different atoms or groups of atoms. None of them matches with the other one. So this is why it is an asymmetric chiral molecule or the asymmetric carbon atom. Now, what does this non-superimposable on its mirror image means? I can give you an analogy to understand. Please listen to me carefully. um, think of your left and right hands. You have two hands, right? One is left hand and the right hands. Both of them look similar, right? Both of them look exactly similar. But when you place on top of each other, let's say you are putting your right hand on top of the left hand, you can see despite looking similar, they cannot perfectly overlap, right? They cannot perfectly overlap because your thumb is now in top of your fifth finger, and your fifth finger is top of your thumb of your left hand, right? So basically that doesn't perfectly overlap. Now by this example might be you have understand or you might not understand, but I will show you some more examples in order to make you guys understand about the chiral molecule. Now have a look at this point. This is a chiral molecule and this is not chiral. How? It is non-superimposable on its mirror image. That means if you put your hand and you see your hand on the mirror, you can see your thumb is actually on the right side and your fifth finger is on the left side. But in the picture, your thumb is on the left side and your fifth finger is on the right side. So this is how they are non-superimposable. They cannot be on the same side. Your thumb here is on the left side, sorry, on the right side, and your thumb here is on the right side. Your fifth finger is on the right hand side, on the left hand side here, whereas it is on the right hand side right here. So basically they are non-superimposable on its mirror image. Let me make you understand again. This thumb is now, let's on the right hand side, this is on the left hand side. Okay, and now this and this are the two hands, right? So this is on the right hand side and this is on the left hand side of your whole hand, of your whole hand. Okay, so basically the real one is on the right hand side and the picture one is on the left hand side. Your both thumbs, this is on the left hand side, this is on the right hand side, your both fifth fingers. So basically they are, this is how they are chiral. Whereas this balloon, they look both the similar in the mirror. So they are identical mirror image and they are not identical. That is why they are chiral. The best example right here, that both of them are on the different sides. They are not on the same side. Here the thumb is on the right hand side of your hand and here the thumb is on the left hand side of your hand. So this is how they are chiral, and they are not identical in the mirror image, but both of them are identical right here in the mirror image. That's why they are achiral and this is chiral. This is what we are looking after, which is chiral molecule. They are non-superimposable on its mirror image. Here in this mirror you can also see this green balloon was on the right hand side of this all the balloons, but this green balloons is on the left hand side of the all the balloons. This is why they are non-superimposable. Now here this hydrogen atom was on the left hand side of the carbon. Now this hydrogen is on the, sorry, this hydrogen was on the left, on the right hand side of the carbon. Now this hydrogen is on the left hand side of the carbon when we put them in mirror. So this is how they are non-superimposable on its mirror image. And also we will also learn about the chiral center as well. Don't worry guys, we'll also learn about the chiral center. And another thing is that asymmetric carbon. That means the carbon atom is attached with four different atoms or group of atoms. None of them matches with the other one. Now, the simplest chiral molecule has two optical isomers. One is positive enantiomer and the negative enantiomer. We have seen about the positive and negative enantiomers before, right? In our previous class, we have seen about the positive and the negative enantiomers, right? Now, a chiral molecule will have both the positive and negative enantiomers. Okay. The third point is if a solution contains equal amount of positive and negative enantiomers, it is called a racemic mixture. Let's say you have 5 dm cube of negative enantiomers and 5 dm cube of positive enantiomers. So it will become a racemic mixture. What does a racemic mixture means? A racemic mixture is optically inactive. It is not inactive. It is not active. It is inactive because the rotations cancel each other out. What actually this two line means is, I will make you guys understand in 1 minute. Just give me 1 minute. Here it was completely positive. That's why it rotated the plane of polarization of the plane polar slide in the clockwise direction, right? And it was negative. That's why it rotated in the counterclockwise direction. But if this optical isomer was both the positive and negative enantiomer of same concentration, 5 degree 5 degree, both of them 5 degree, then this would have rotated in this direction and this would have rotated in counterclockwise direction. So basically both the rotations were cancelling each other out, so it would have been completely vertical just like the previous one, because one is rotating in this direction and the other one is rotating in this direction. So both these rotations cancel each other out and it becomes completely vertical. So when you have the same concentration of positive and negative enantiomers in a solution, it becomes a racemic mixture, which means the two rotations cancels each other out. Okay, and there is no rotation. It remains completely vertical. So basically we are completely done with the chiral molecule. On the next video we will learn about the chirality and the mechanism.